everyone. My name is Dr. Bahati Ilembo. I am excited to take you through today's session, which is on correlation analysis. In this video, we will explore how to analyze the relationships between actually different variables and understand the connection. You will learn also how to use the correlation analysis to measure the direction as well as the strength of the relationship. Now, in each session or lesson, we need first of all to know what we're going to achieve. So the learning outcomes, I've outlined here 3 of them, but there could be many. One of which should be to enable you explain the concept itself of correlation and its importance. Also, you should be able to interpret what you call the scatter diagram and the correlation coefficient, which is a measure of correlation. And lastly, we expect you to be able to calculate the correlation coefficient and analyze the strength and the direction of this relationship. Now, as a preamble to the concept, we are saying if you consider 2 variables which are related, like say cells of ice cream and a daily temperature, we know from the common sense perspective the cells of ice cream would always be affected by the condition, the weather condition, and in this case the temperature. And we suspect that when it is hot, we can sell more of ice cream than when it is cold. So we anticipate that there is a relationship between cells of ice cream and say daily temperature. And for that matter, you can as well mathematically label these 2 values to signify how they relate to each other in order to also be able to calculate the correlation coefficient itself. So if we let, say, X be the daily temperature, so we can say your X be, say, daily temperature, okay? And then your Y be cells of ice cream, okay? Ice cream. And then the point of interest. So the interest here will be, are they related? Are they related? This will be the question of interest. Are X and Y related? Okay. So we are going to use actually data in order to ascertain whether these 2 variables X and Y are related. And therefore, for that matter, correlation now will help us to measure the association or the degree of association between these 2 variables, the cells of ice cream and the daily temperature. But before we proceed further, the next important assumption will be that these 2 variables has to be need to have what we call causal effect relationship. So we will be interested to see whether they have what we call causal effect relationship. Do they really cause each other to happen? Does daily temperature lowers cells of ice cream, or does you see do they affect really each other? Do they affect really each other? So having assumed that one variable is related to another, that's where you can proceed with the, doing the correlation analysis. But before also we proceed further, and given this causality assumption, what we're saying here now, we should label these two variables as being, for example, the x here, the x here will be the independent variable, and the y here will be dependent variable. So independent variable and this dependent variable, which means the direct temperature causes cells of ice cream to change. So when direct temperature changes, when it is cold, it means you can sell less of ice cream, and when it is hot, we can sell more of the ice cream. So sales of ice cream depends on the temperature. So if we assume that, then I'll go straight now to show you how do we calculate theoretically the value of the correlation coefficient. So the value of the correlation coefficient now, which is denoted by a lowercase r, is normally given by this formula here. It's given by this formula here. So r is equal to n times sum of x, y minus sum of x, sum of y, then divide by the square root, you see now, of n sum of x squared minus sum of x into bracket squared, the whole thing in bracket. Then you do also for y. So sum of y squared minus sum of y into bracket squared. But the whole thing is under root. So if you have now the paired observations, so for paired observations, x and y, xy, you can calculate the value of the correlation coefficient, which normally ranges between -1 and +1. So the value of correlation normally ranges between -1 and +1. And how do we interpret this? So we are saying when the value of the correlation coefficient is towards the negative side, but not more than -1, then we are saying the relationship is negative. And when the value of the correlation is positive and towards this direction here, we are saying the correlation is positive. In other words, when the value of r is negative, we are saying we have a negative relationship. And when the value of r is positive, we are saying we have a positive relationship. The question perhaps would be, what if the value of r is -1, is +1, is 0, or is between either of these values here? How do we interpret this correlation coefficient? We are saying when the value of correlation coefficient is exactly -1, then we have a perfect but negative correlation. When the value of the correlation coefficient, R, is +1, and we are saying we have a perfect positive relationship. And of course, these are all strong relationships. But when the value of correlation coefficient is 0, then we are saying we have a 0 relationship. But there are cases where the value of R is somewhere in between. For example, R can be equals to 0.64. What do we conclude about this value of R? Or R, say, is equal to -0.03. What do we conclude? So we are saying we can have very strong, perhaps weak or moderate relationship, depending now on the size of this correlation coefficient and how it departs from 0 towards -1 or from 0 towards +1. Preferably, when R is from 0.5 onwards towards 1, then we are saying the correlation here, or the relationship, it is moderate, going to higher, a higher relationship. So you see the values may now be interpreted based on the magnitude and how they depart from 0 towards 1 and how they depart from 0 towards -1. So that's how we can at least interpret our value of the correlation coefficient. Now let us maybe consider a case also on how we can assess the correlation using what we call a scatter diagram. A scatter diagram. So if, for example, you have such data like these ones, so you have, say, price of say maybe goodie X, and then we have the number sold of goodie X. Okay, if you have this kind of a relation here, so we have, say, for example, the price is 18,000. Maybe this price is in 1,000 shillings. So we have 18,000 here. We have 20. We have 20, right? We have maybe 25. This is a hypothetical example. So we have 27, and maybe we have 28 and 32. Maybe 28 and 32. So these are the price of goodie X. So they varied maybe accordingly this way. And you have the number, how much was sold. Maybe when the price was 18, only 8 units were sold. When the price was 20, maybe only 6 units were sold. When the price was 25, maybe only 5 units were sold. And then 2 units were sold when the price was 27, and then 2 units when the price was maybe 28, and only 1 unit when the price was 32. So now you see, theoretically, it can be hypothesized that the price of a good is related to the number of a particular good sold. And we know this from the economic point of view. When the prices are higher, we normally buy less of the commodity than when the price is low. When the price is low, we buy more of that commodity. Now, before you proceed with the correlation analysis, you can also plot a scatter diagram, a diagram which consists of scattered dots, in order to portray at least the first image, or we will get an impression of what really could be the relationship in terms of the direction, whether it is positive or negative. So when you plot a scatter diagram here, you will realize that there exists a kind of relationship between these price and the quantity or number of a good sold. But if you decide to plot this, you will realize that you may have such a scatter plot like this one here. So we assume this will be the number sold will definitely be in the y-axis. So this is number sold, and then the price will be in the vertical axis here. This is the price. So roughly, if you can plot this, okay, so maybe 10, 20, sorry, it can be a 5, maybe 10, 15, maybe 20, then 25. So this is a price. 25, maybe 30, and 35. So this the horizontal axis is for price, but the vertical axis is for the number sold. The number sold. So we have here 1, 2, 3, 4, 5, 6. I want just to show you how a scatter diagram is plotted and how you can depict the kind of the relationship which might exist before even going to calculating the correlation coefficient itself. So you see now, when the price was 18, maybe somewhere here, the number sold was 8. So maybe it should be somewhere, maybe up here. And when the price was 20,000, only 6 items were sold, perhaps maybe here. And when the price was 25, only 5 items were sold, maybe somewhere here. When the price was 27, then 2 items were sold, maybe here. Maybe also when the price was 28, 2 items were sold, perhaps here. And when the price was 32,000, the number sold was perhaps 1. So you may be somewhere here. You see now, this is a kind of a scatter plot, which consists of dots which are scattered within the graph, of which now, if you look at the dots, you realize that these dots are sloping downward from left to right, which shows the negative relationship between price of good X and the number of good X sold. So this is the negative relationship, which means when the price increases, then the number sold of good X will always going to be decreased. So that's the negative relationship which we are talking about. And if you calculate the correlation coefficient now between the price of good X and the number sold for good X, you will always get the negative value. You can witness this when we go to the specific calculations of the same data using the correlation coefficient formula. So if you go back to the formula, the correlation coefficient formula, which I presented the area on, I want now to use the same data to determine the correlation coefficient now. So if you look at that formula we used, if you remember, you said your R is equal to sum of x, y, minus sum of x, sum of y, divided by the square root, okay, of n sum of x squared minus sum of x into bracket squared, and then you had n sum of y squared minus sum of y into bracket squared. If you use this formula, what you need to capture from this formula is that you need to establish what is the sum, what is the n, first of all. N is the number of paired observations. Number of paired observations. What is sum of xy? What is sum of x? What is sum of y? What is sum of x squared? And what is sum of x? Okay, with x, of course, into bracket squared. And what is sum of y into bracket squared? So once you get these values here, you are able now to calculate or to obtain the correlation coefficient. So you realize that, for example, the sum of x would be 150. If you go back to the data which I showed you earlier on, the sum of y is 24. If you go back to the data which I showed you earlier on, the sum of y squared is 134. The number of paired observation were 6. If you remember, very careful. The sum of x into bracket squared is 22,500. Sum of y squared is 576. 531 is the sum of x, y. The sum of x squared, which is 386. So once you get these, so these are the values which, when you plug in this formula, then definitely you are going to get the value of R. The value of R, which is the correlation coefficient, which is minus 0.96. Minus 0.96. Now, the good thing also nowadays with the use of calculators, you can also fit in the function of the linear regression in the calculator, and then you can retrieve all these values once you have entered the paired observations x and y. Now, this is the value now of the correlation coefficient, which is minus 0.96. You remember the value of R range between minus 1 and positive 1. And we said when R is closer, the more closer you go to either negative 1 or positive 1, the more stronger the relationship becomes. But now your value of R here is 0.96, which means, first of all, it is a negative relationship, but also strong because it is very close to minus 1. So we have a strong negative relationship between the two values which we studied, which are the price of the commodity X sold and the number or the quantity of commodity X sold. So the relationship is negative, which means when one of them increases, the other one goes in the negative direction and vice versa. So this tells us the strength of the relationship, that there is a strong relationship, but also the direction, which means there's a negative direction. So that's what the correlation coefficient really can offer up to this point, So in summary, we have established what is the correlation coefficient as a concept. but also we have managed to calculate the correlation coefficient, and finally we have managed to interpret the value of the correlation coefficient by really examining the nature of the relationship that exists between the two variables under consideration. And therefore, understanding correlation concept now helps somebody studying relationships using, you can use now real world data to assess the relationship between variables, if at all exist, but also get an informed decision based on the data. Thank you very much, and let's meet in another session.